Hello, everyone. Welcome. I'm going to wait just one more minute, let some of the people finish joining, and then we can start. Thank you again for your time. Okay, well, a good morning or a good afternoon or a good evening to all of you, depending on what time zone you're in. Welcome, thank you for taking the time to join us for this webinar on automation and Rajant's mesh network. I hope you can all hear me well. We have tested this a couple of times and we have a large crowd joining us today, so that will be fun. I hope you and your family are safe during these special times. My name is Sagar Chandra and I focus on Latin America with Rajant. Along with me, we have Samuel Brito of SITECH Brazil. He wears many hats and I will pass the control to him very soon so he can introduce himself and share with us some of the interesting projects that they have undertaken and successfully delivered using the Rajant solution. First, a bit of housekeeping. Like most webinars, this webinar will be recorded, is being recorded. All the audience is on mute. And of course, we are interested in your comments and questions. So to the right, you should see some drop-down options. And one is titled questions. There you can type your questions and we will do our best to address all the questions during the question and answer session at the end. If for whatever reason we're not able to, we will respond to you individually. Also, including our email, Samuel and my email, you can contact us later with anything special you have. For our friends in Latin America, si prefieren conversar con nosotros en español o con Samuel en portugués, estamos disponibles. Okay, so it looks like we have a strong group joining today. Let's get to the fun part of the webinar. So this journey to automation in the mining industry, a lot of us may remember the days of paper tracking and manual voice commands. Then came the asset tracking, fleet management, machine guidance, all the software solutions, wireless solutions. And that's obviously where Rajant started to make a big impact. As most of you know, there are some new names and partners in this webinar, but most of you know Rajant is focused on mobility. And now the evolution of mining to automation has turned into teleoperation, autonomous use of drones, etc. Each step, each change has meant a need for more and more stable, high bandwidth wireless foundation. When it works, nobody knows about it, but when it doesn't work, then everybody talks all the way through the application. So just a minute overview about Rajant. We have customers and partners pretty much everywhere there is mining around the world. For those of you who may not know really the reason why Rajant has been successful, I usually just talk about 4 key points. We have no central controller. We use multiple frequencies, which allow multiple levels of redundancies, so your network does not go down. And your applications where you have invested millions of dollars also does not go down. We offer true mesh, that's mesh between all mobile, all fixed units. And these photos that you see, the black box and the white box, and we have different models. They may look simple, but they actually pack a lot, 4 in 1 feature, basically. They act as a repeater, they act as a client, they act as an access point. So let's go back to the focus of this webinar, automation projects. Last year, of course, not much has happened this year because of what, but last year and before that, we had a coal mine in the USA use Rajant for teleoperation. We had a copper mine in Chile, and this is where Samuel comes in. There are 3 very unique, interesting projects that he has been part of, delivering teleoperation autonomous solutions to the mining industry. So I shall now pass it over to Samuel Brito, and he will introduce himself. Go ahead, Samuel.
So good afternoon, good morning, good evening, everyone. Sagar, just check you can see my screen.
Yes, perfectly. And I will check the questions, make sure that everybody else can see it as well. No, everybody can. We're looking good. Thank you.
Great. So thank you, everyone. And thank you, Sagar, for the invitation, for the opportunity to be here talking to many places on the world about what we're doing here in Brazil. And thank you for your time, for being here with us, okay? My name is Samuel Brito, and I'm responsible for the distribution of Rajant in mining market here in Brazil, and also for the development of new business in SITECH Brazil, okay? So I'll quickly cover about SITECH, and then we are going to move forward about for Rajant and for the automation projects in Brazil, okay? So regarding SITECH, I don't know if all of you are aware, but SITECH is a company that was created due to a partnership between Caterpillar and Trimble. And SITECH Brazil is a company that really aims to deliver customized technology solutions to each specific customer operation. So we can deliver solutions of technology, monitoring, energy efficiency for mining, ports, and construction markets, okay? So about our group, SITECH is an international company and with more than 100 companies over the world, but inside Brazil, it is managed by SITECH Group. And SITECH Group is one of the largest Caterpillar dealers working for more than 70 years in the Brazilian market distributing heavy machinery, okay? And SITECH, we work with some exclusive brands. Of course, as a partner of Trimble, we represent Trimble for the technology of machine control for the construction market, okay? Also, the Rajant networks providing the InstaMesh protocol to provide unprecedented network availability and reliability, okay? The Neville remote controls that are designed for heavy machinery and can be customized to every type of machine. Propeller is a platform to process images from drone flights and provide useful data, and also allow 3D projects for machine control to be designed. So there's a link between Propeller and Trimble through a platform called Trimble Stratus, okay? And finally, we have the Renter Fuel Catalyst. It's a mechanical catalyst that allows diesel consumption reduction, okay? So moving forward for Rajant networks in Brazil, okay? Talking about the Brazilian market, we've been working together for around 7 to 8 years now, and it has been a very productive partnership, around 85% growth per year. And that happens because we can improve our customers' operations performance in a very strong way, okay? About the Rajant territory in Brazil, currently we are inside more than 23 operations with more than 1,400 equipment sold, okay? And some of our main customers, we are, as you can see, we're inside some of the main mining customers in Brazil, and we're still working on the others. So certainly this list will be increased by the end of this year. And what really allowed that numbers to happen during this time? The answer is the results of operations using Rajant were greatly increased. And there are some characteristics of Rajant that allow that to happen. First, because Rajant enables the true power of a real full mesh network, where every equipment really communicate to each other simultaneously in multiple frequencies. This creates a big net of communication with paths in different frequencies, creating redundancy of frequencies and of equipment. So the results are much more reliable network for mining operations. Also, another detail that allowed Rajant to prove its value inside mining operations is the capacity to automatically adapt to dynamic operations. As we already know, mining demands dynamism, and its network needs to be available during movements, never breaking for handoffs. So what happens if equipment moves? As the equipment starts to move, it won't lose the many links it has to communicate. Before it loses the old links, it creates new ones, and they get closer to other radios. This is why Rajant uses the slogan, make, never break. It is moving, but it's creating new links, so the radio and the equipment will always have links to communicate. So the effect of this ability to adapt to movement is an extremely reliable network, exactly what miners need for their operations. Never worry about networks and communications. So considering the specifics and the details of Rajant networks we spoke before, how is it going to work in a real operation? Exactly as we explained, every equipment that has a Rajant radio installed will talk to the next machine or physical structure. Excavators communicating to wheel loaders, then to drones, pickups, trucks. Everything will talk and create a huge network of multiple purposes. Telemetry, dispatch, fatigue monitoring, high precision, video surveillance, and VoIP. Of course, automation, everything in the same network. So inside the Brazilian market, we're using some models of Rajant portfolio. The single band radios, the JRs, the dual band radios, the ME4s and the KM3s, working on 2.4 and 5.8 gigahertz. Also, we use a lot the 4-band radios from the Alex family, which can have also the 900 megahertz included. Okay. We'll use these models according to previous network planning and to what the customer needs to communicate over the network. So moving on to the real examples of operations using Rajant networks. The first operation that we deployed in Brazil soil was the the ore stackers and the reclaimers operations. These machines needed to have constant communication, and each time the network had an issue, the whole operation stopped. So the time to restart everything was considered as a production loss. And as these huge machines movemented many tons per hour, every minute was precious. So we considered use the 4-band radios to bring equipment and frequency redundancy. Okay, and to confirm the increase of performance and mainly what we could save in production losses if we deliver a reliable network such as Rajant, we proposed a proof of concept. We tested the current solution from another brand and checked the profile of the network issues and the production stoppage, of course. Considering 3 machines to be analyzed, on the left side of your screen, you can see how it was. Each line is a network failure and each color is a machine. After that, we deployed the Rajant solution and repeated the same analysis for 30 days. We had the profile on the right side of your screen. But it is important to highlight that every line after the Rajant deployment was due to machine maintenance. So as the machine was shut down, also the radio was not communicating due to lack of energy, but it was not a failure. That proof of concept allowed the customer to present the solution inside its corporation and defend that it brought a level of 99.9% of availability. The result was so impressive that they started to invite Rajant to new and more exciting challenges. So we're helping these mining companies to properly put many autonomous projects to work. Autonomous drills, autonomous dozers, and different types of remote cabins. Rajant brought the desired level of latency, throughput for cameras, all the technical requirements for these solutions to work properly. We will talk more about these types of projects in this presentation. Another very specific type of operation, but also with the same level of importance and linked to the need of reliable network. We recently deployed the Rajant solution in the truckless mining. Similar to the stackers and reclaimers operation, in this process, each part of the system needed to communicate to each other in order to allow the process to happen. If a network failure happened, the whole process would stop, okay? After we passed the POC protocols challenges and deployed the Rajant solution, we allowed this customer to move from a scenario of many $1 million losses to not only zero losses, but also the production capacity increases, okay? So the most recent project of automation operating over Rajant networks was created after Brazil's recent episodes involving mining dams. We were challenged to design a way that companies would be able to remove material from mining dams without the presence of humans in the dangerous areas, which include not only the dam itself, but the areas where the material could be projected if a collapse happened, okay? So, including all the technologies inside SITECH Brasil portfolio, we created a remotely controlled system for dam decommissioning operations, where it would be possible to operate heavy machinery from a safe distance with the presence and productivity, okay? Why we were able to deliver this type of project? Mainly because we are working in the last year on a request to apply remote control on amphibious excavator that worked inside mine dams, moving material. There were a risk that this machine could fall, and so it was needed as this operation was manned. The operator would be outside the machine, operating from a safe distance or from an office, seeing the operation through cameras or on a monitor or a tablet. And as we were really advanced on this solution, we were able to support the remote control for dams. So how the project would work? Considering the dam decommissioning project, we would need to place not only one machine inside the risk area, but many machines and of a lot of different types: trucks, wheel loaders, excavators, dozers. All these machines will be remotely controlled from a control shelter that would be deployed on a safe area indicated on the illustration in the blue zone. All the red zone would be risky to place anything or mostly humans close to it. In this way, operating from a safe area, we wouldn't need any human interaction on this risk area. So, and what is the general structure of the project? Basically, we will need to place cameras on strategic positions of each machine and high precision systems over the machine to control and allow the machines to operate according to a design project with blade automation. We will need to place Rajant radios to allow everything to be transmitted in real time to monitors inside the control shutters And after all, we would use drones to collect images of the operation in order to upload these images into a platform, analyze and deliver updated data for the operation, and then update the 3D project, and finally send it back to the machines using the high-performance network. The first technology that we deployed for the solutions, and it's almost like the heart of the solution, is a remote control. And why we choose the naval remote control? We choose it because of the same reasons that we choose naval to be a brand that we represent. They could customize the remote control for any machine necessary. Also, we could operate machines to up to 1 kilometer away, and we could include the automatic blade control of the high precision systems. We could operate the machines from a joystick or a workstation inside a control shelter. As you can see, we have many examples of machines already working with the system over the Brazilian mining market. And one important achievement for us was the development of a remote control for trucks. We couldn't find a ready solution on the market, and trucks were a big part of this project. So again, it was only possible because naval have the adaptability and the capacity to customize its technology to different types of machines. As you can see, the truck has all the cameras positioned strategically on the sides of the truck, and also the network devices of Rajant over its cabin, okay? So as we had the technology to remotely operate all the machines, we needed to move forward to the infrastructure. We knew that we needed to use something that we could place in the safe areas, but we need to develop a control shelter. And this next step, we needed to provide the proper infrastructure, not only to allow the operators to be inside a safe and ergonomic structure, but also that could bring all the technological systems to allow the operation remotely, okay? Rajant communication, workstations, monitors, servers, access control to only authorized personnel, air conditioning systems, generators, no brake systems, video monitoring, and so on. So we designed our infrastructure. We designed that solution with our infrastructure partner, RD Trailers, which are also a Rajant strategic partner. And then this control shelter was designed to allow up to 4 machines to be operated inside it, and all the technology, everything needed to allow the remote operation. So our design came to life on the second semester of last year, and the results were great. As you can see, we had everything needed to allow the operation from this control shelter, all the telecommunications devices, and the workstations inside it. Over the monitors, the operator could have all the images from the strategic sides of the machine, and also the vision of the top of the shelter to see and check where the machines he was operating, if it's close to another machine or close to an obstacle or an object. All these cameras were configured in HD, in high definition. So the network was the core of the whole project. If the network failed, the whole operation could be compromised because the operator couldn't have the confidence to operate with delay or the lack of proper video transmission. Also, we could improve the solution, bringing devices that could make the operator experience of operating a heavy machine remotely closer to what he would have inside the machine cabin. So moving forward, the next technology that we deployed on this solution is the high precision 3D systems, okay? Clearly, the safety was the main point of this project, but also we needed to grant productivity and precision to what was being done by the machine. And that's the great thing of technology. We included Trimble machine control to allow not only the indicative high precision systems to guide the operators, but also to allow blade control for the machines. The blades would be automated and move automatically according to the position of the machine inside the operation. Basically, the technology includes sensors and GPS antennas on the machines that receive positioning information of a satellite constellation and the correction of this information from a base station. This correction is called RTK, and it is what allows the machine to reach centimeters of precision. It is important to highlight that this correction may be transmitted through radio network, and also the 3D project can be sent over the same network. Again, radio was being used as a multi-purpose network. So we used excavators to execute embankment and excavation operations guided by the 3D project, and mainly to eliminate the topography team needed on the process. Also, we use dozers to the material handling with blade automation, spreading the material in layers evenly, and also eliminating the need of the topography team in the process. Finally, the process would be updated using drones to collect images from the operation. These images can be uploaded to a platform called Trimble Stratus, and this platform can analyze these images and extract many data and useful information from it, and mainly it can use the images to generate the 3D project and constantly update the operation project and send it back to the machine through the radio network in a cyclic process until the end of the decommissioning operation. So basically, the execution will follow a simply but deeply designed process. After the machines and the control shelters were assembled and deployed, the drones would fly to gather the images and then upload it into Trimble Stratus, process it, and create the 3D projects, and then send it back to the machines through the radio network. In this way, we wouldn't need to have human interaction in the risk area, and then we could deliver the first unmanned technology for them, the commissioning process. So these are just some of the automation operations running over radio network. And I wanted to thank you all for your time and the opportunity to share a little bit of what we're doing here in Brazil. Here are my contacts. Please feel free to contact me and Sagar to understand more about any of our products, okay? It will be a pleasure to help you. Thanks again, Sagar, for the invitation, and I think it's time to open for questions and answers, isn't it, Sagar?
Yes, and Samuel, thank you very much. I think the photos and the videos helped communicate the challenges and how you were able to deliver that. So thank you again for kindly sharing all these details. We do have some questions, so I will just read some questions that have already come in. So Watson asks, what are your typical latencies given a well-optimized network, and what is the practical achievable speed? So Samuel, for example, for the truckless project, what was the latency that was required that we had to
for the truckless operation, it was a requirement that we used at least 80 milliseconds of latency.
Did you say 8 or 80?
8, 7, 8.
Okay, 8. So to Watson and the rest of the audience, 8 milliseconds, that's super fast, and that was a reason why the mine was having challenges keeping their operations running because the previous brand was not able to deliver 8 milliseconds. And Samuel, for the teleoperation, I know that they are sometimes not as demanding. What was the latency that you had to deliver for the teleoperation?
In the terms of the teleoperation regarding the dam decommissioning process, well, of course, we had to deal with very low latency, and the exact number I'll have to check with the tech team. But the main struggle that we had is to allow so many cameras to operate in the same network. We're talking about 20 to 30 machines using high definition cameras. And I'm talking about 5 to 7 high definition cameras over each machine. So we would have much more than 100 high definition cameras in the same network. That's why we use the LX5 family radios, and also we include an slipstream to increase the capacity of the network, the bandwidth that the network could handle.
Perfect, perfect. Thank you. Actually, you answered 2 questions. You answered the next question as well, which was how many cameras were in that project. So thank you for that. That is a very, very aggressive demand and for a stable wireless communication. Going back to the question about latency from our experience, because we have experience with various different camera providers and teleoperation providers as well. Typically, most of these vendors ask for a latency of less than 100 millisecond. In a Rajant network that's well designed, we are usually less than 20 millisecond. And as you heard about the truckless operation, we were able to deliver 8 milliseconds. So to the question about latency, we are well below what any manufacturer has asked for. In terms of the question about what are the achievable practical speeds, well, there you have it. I mean, high definition cameras, not 1 or 2, but 20, 30 at the same time. There's a question from Paul, what sales and support network do you have in Africa? I'll take that. So Rajant works with partners around the world. We have authorized partners who go through training and are certified to take care of a network like Rajant and to provide good support to the end user. So Paul, I shall send you a list of our authorized partners in that region. Good to hear from you, Paul. Okay, there's a question. 1 second, I just have to scroll. How do you differentiate? Ekaterina is asking, how do we differentiate from our competition in the regions interesting are Russia, Panama, and the US. So let me take that. So the slide that I had earlier, and let's see if I can go back to that, about the 4 key features that Rajant offers. Samuel, do you mind sending the presentation mode back to me, please? Or Diane? Those 4 features are the ways that we have been able to explain why Rajant is unique and the benefits that we can offer. Thank you. 1 second. So I'll just put this back again. So I can get there. There you go. We don't have a central controller, which makes our network extremely fast, and that's why we're able to deliver these low latencies. We use multiple frequencies because with multiple frequencies, every mining operation, open pit, underground, you are going to run into interference. And with multiple frequencies and multiple antennas, we offer you the highest availability, which means if one frequency gets heavy traffic, the Rajant node automatically switches to the next frequency and the different type of antenna, if it's a different side of the antenna, if it has to use it. The mesh, the fact that the kinetic mesh means that every node talks to every other node. And most of you know this, but I'm just addressing the question here. So this is something that we offer, which is unique. There's a couple more questions. Let me just get there. Which model of the breadcrumb was used, Samuel?
For what project?
For the teleoperation.
Well, it's funny to take a look, but all these automation projects, they use the 4-band radio, the LX5. For the truckless and the stackers, we use the LX5 2295C, which includes the 900 megahertz frequency. For that operation, it is, as the packets are very small, but they need to communicate the whole time. Sometimes the 900 megahertz frequency is useful. But for the DAM project, we use the model LX5 2555D because we needed to use more bandwidth, as the 900 wouldn't be that useful for bandwidth. We prefer to use more frequencies of 5.8. Okay.
Okay, thank you. There's a question from Edward. Using Radiant Network, is it possible to transmit voice? The answer is yes. We actually have underground mines in Mexico that had a 3-month testing period because they wanted to communicate with the surface and they wanted to use digital phones and use the Radiant Network as the backbone. So they have shown, and of course now we're in the process of installing all those radios, but they have shown tested and successfully demonstrated voice over IP using the network. There's another question here. How much delay, Samuel, I think this is for you, if you know, how much delay is there in the transmission of the video to the operator in the teleoperation project?
Awesome, great question. Well, if anyone knows about Radiant, they can see that we were not conservative on the number of equipment that placed on this project. That's because we needed no delay, because if the operator had any delay on the operation, they wouldn't have any confidence on what they are doing. So they would have the feeling that they had to stop and see what happened. So this would deeply decrease the productivity of this project. So as we aimed not only safety, but we needed also to take a look over the productivity, we had to grant no delays. And this was, of course, something that we need to check over and over again, and finally find the exact design of the network to grant the operators the total confidence that what they're doing, it's really happening, and they are seeing through the monitors.
Thank you. That question was from Manuel. There's a question from Mahmoud about, do we provide connectivity for machine control system by TopCon? We work with, and we have successfully worked with various providers of machine control around the world. I don't see any reason why not, as long as there is an RJ45 cable, or it can act as a Wi-Fi client. Mahmoud, we are happy to review what configuration you have after the fact. There's a couple of more questions. Manish is asking, do we have any installation on underground mine? What is application length area covered in underground mines? Manish, yes. So we have installations in South Africa and Mexico. Those are our most recent projects, and with underground mines. I'll have to get you a little bit more detail on the length and the application. I know they are using basic fleet management system in Mexico for phase 1. However, for phase 2 and 3, they plan to go with automation, voice over IP. They have also tested doing video calls with the operators. Some of the operators will be down at some of the tunnels with the surface. And in South Africa, we have a case study on our website, but I will make sure that our team forwards that to you. We have your contact information. Nando is asking, let me just read this in Spanish and I'll just translate it. Es decir, Okay, so Nando is asking about drones and if that can be done with the Rajant network. The short answer is yes. Samuel, I believe do you have something on drones?
Yes, let me just find it. 1 minute, please.
Okay, I'll pass it back to you. I'll pass the control back to you. The short answer, Nando, is yes, we have a breadcrumb model. I have it as well, actually, a photo here. But we have a breadcrumb model that is light, is designed to be installed on drones. And we currently have customers who are using this. So it can be installed on any drone of your choice. Rajant does not make drones, but we provide you with this radio that has the same InstaMesh protocol that can communicate with drones in the air or at the same time communicate with Rajant breadcrumbs on the ground. I'll pass you the control, Samuel.
I'm just searching for just 1 minute.
No problem.
Well, but yes, as you already explained, Sagar, yes, we can deploy Rajant over drones. And also, it's important to say that we cannot only do that, but mining customers, they're asking for solutions with that. Sagar, I think I don't have the slide here, but we can talk about, yes, I found it. Just 1 minute.
In the meantime, there's a question from Ankit about, can you help to deploy a solution for various trucks, vehicles in an area of around 5 square kilometers? Absolutely, absolutely. We have radios installed and we provide coverage in areas of 20 kilometers by 25 kilometers. So 5 square kilometers is not a challenge at all. Thank you. Everybody hopefully can see this slide from Samuel. Go ahead, Samuel.
Well, as I was explaining about the drone with Rajant, one type of project that mining customers already asked for us, and we were working on that, is that when we're considering the blasting operation, they have to move all the solar trailers outside of the area that the material can be blasted. Okay, so the operation can only be reestablished when they move the solar trailers back to its original position. So if we could make it faster, and in this case using drones, the operation could be restarted before the solar trailers are moved to its original position. Not only that, we can work on perimeter monitoring, perform wireless site surveys, we can make solar panels inspections, we can check critical infrastructure, we can perform also inspections, and of course, bring fast communication reestablishment after the blasting operation.
Perfect, thank you. Just 1 second. Can you provide backbone solution for railway operation and signaling? That's a question from Paul. Yes, we actually have a project ongoing with a train control system here in the US, and outside of the US, we are looking at a couple of opportunities as well. Short answer is yes. Couple of more questions coming in. 1 second. How many, Harun is asking how many driverless truck-based mining projects executed in India. I am not aware, but I will ask my colleague to get back with you about how many installations we have in India. There's a question about Komatsu and Comtrax Plus. So we have various customers that use Komatsu solutions, and we've integrated with that. Comtrax Plus, I understand what that is at a high level, and I believe in Peru we have a customer who does that. So short answer is yes. Igor is asking, is there any systems for which Rajant is default communication system? We have a number of strategic partners that have standardized on Rajant. If I understood your question correctly, Igor, perhaps I didn't, but yes, we have some mining corporations that have standardized on Rajant. We have autonomous truck manufacturers that are standardizing on Rajant? So the short answer is yes. Michael asks, is satellite communication often used with Rajant solutions? Not really. So far in mining, we can, and of course there's a need sometimes to connect with a microwave or a point-to-point radio. Satellite has not come up yet in mining to my knowledge. However, in the train and transportation industry, for example, in Brazil, there are thousands of kilometers of railroad. We're working on one project where, yes, we will be plugging into a satellite radio at some point. Rajant will take over at some point. There will be a mix of technology. So it is possible to connect with multiple technologies. I'm just looking at the time. We still have some time, so the questions keep coming. So Samuel, if you're okay, we'll keep going with the questions.
Perfect. Go ahead.
How far was the remote cabin, Samuel, in the teleoperation?
Okay, the remote cabin was considering the number of projects and operations that we studied. We considered a range of 1 to 1.5 kilometer, but this is directly related to the size of the dam. We studied some dams, some projects, and we considered that distance, but it was just because we considered the dams that had that size. If we need to work on a different size of dam, we can easily develop a different topology to cover the size of the dam, bigger dams, smaller dams. We have our partner of infrastructure, RD Trailers. They can develop solar trailers that can float over water. They can move over water in amphibious design. Okay, so it's always going to the topology and the network planning that we need to study before working in different sizes.
Excellent. Ricardo says, thank you very much, excellent presentation. So I think that's all for you, Samuel.
It's for us. Thank you.
Arun asks, how about oil and gas and the use of Rajant? So absolutely, we currently have a customer in Texas that has 20 kilometers by 25 kilometers. I believe there are 400 stations that were connected using Rajant breadcrumbs, a different combination of Rajant breadcrumbs. And we have ongoing interest from Colombia, Argentina, and the Middle East. Actually, talking about the Middle East, there was a question, I believe, from Mahmoud that said, who are your partners in the Middle East? Absolutely, yes, we have authorized partners. I will make sure to, we're capturing all the questions, so I apologize if I'm not getting to all the questions, but we will respond to you in writing to your contact details. Sean, thank you for mentioning about the question about if this is being recorded. Yes, this whole webinar has been recorded and will be available on our website for yourself or for others who may have missed it. And I believe the questions are slowing down now. Is it possible to integrate, Edward asks, integrate radio's IP over Rajant with other radio systems? Our integration is at level 2, or maybe to put it a different way, we can integrate with anybody that can connect as a Wi-Fi client, because the Rajant Mesh network, its objective is to provide mesh connections super fast. At the same time, these radios, if you remember my point about 4-in-1, the Rajant node acts as an access point, and it can provide a regular Wi-Fi signal that your a digital radio, a laptop, a tablet, a phone, if you can connect to a Wi-Fi system anywhere, you can connect to the Rajant's access point Wi-Fi network. So integrating IP radios, yes, as long as those radios can act as clients, they can be clients to the Rajant network. You will not have a full Radiant system in that case. The weak link when it comes to stability or throughput or latency will be those non-Radiant devices. But we do this often in many migration projects. You know, customer is using brand X and they want to go to Radiant. So we coexist with multiple brands at the same time as they transition over to Radiant. There's a question about blind spots in underground mines. So how does Radiant deal with that? So this comes down to something that Samuel mentioned, which is each breadcrumb uses multiple frequencies. So we know that some frequencies are better at propagating through a tunnel and line of sight issues than others. The second point is, of course, a design. You know, we have to work on a good design to ensure that we have good communication and coverage.
Sagar, I think I have some slides here about the setup of Radiant in the Amandelbult mine. Perhaps it's interesting to show how the results were when we are talking about an underground environment. I'm just
perfect. And that's a good point. We also have projects with automation underground. Of course, the focus of this was mostly, entirely on open pit. But thank you, Samuel, for bringing that up. While you bring that up, there's a question from Craig. What is the range of a Radiant breadcrumb over water? So in the Caribbean, we had a very interesting project. I believe it was 12 or 14 months ago. And we had tremendous performance. I believe it was almost 11 kilometers. I want to say 10 kilometers, 11 kilometers, but Craig, we will respond to you in writing. If you have a project that requires transmission over water, that has not been an issue with Radiant so far. I know that water causes a lot of interference, but we had a very good deployment.
Sagar, can you see my underground operation screen?
Not yet.
Just a moment, please. Tell me when you see it.
Yes, we got it.
Okay. So this regards a proof of concept that was done with a customer. This is a case that is on the internet. Everybody can see and check what happened. But we used dual frequency radios and a set of antennas that we designed, of course, to reach the level of performance we wanted. But we placed the radios in infrastructure models for underground mining, and we tested the performance. Sorry if I have some information in Portuguese, guys, but I'll explain. We tested the performance of the communication as we were creating higher distances between the two infrastructures and the radios. And more than that, when we place the radios inside the tunnel in a curve, okay? So first we tested in 100 meters with a line of sight. We had 5 milliseconds of latency and 79 megabits per second of throughput. We placed it inside the tunnel, 200 meters with no line of sight. The levels of latency and throughput were almost the same. 300 meters with no line of sight, more or less the same performance. 400 meters with no line of sight, same performance. 500 meters, same performance. And 600 meters and 70 meters, no line of sight, 6.4 milliseconds of latency and 68 milliseconds megabits per second of throughput. Okay, so this is more or less the results of the tests. Of course, this was one test. Each operation has its own challenges, but we are always open to check the customers' challenges and see what we can do to bring a reliable network for them.
Perfect. Good to have some real hard numbers that we can share with the group. So we're just a few minutes away from the end of our scheduled 1-hour webinar. Again, you have Samuel's email and my email. This webinar is being recorded. If you have any other questions, don't hesitate. Thank you so much. It was a pleasure, and thank you for all the questions and the comments from the team. We look forward to doing this again. Thank you.
Thank you, everyone. Have a good day and the rest of the week.